Welcome back to linear algebra. Let's jump into Anki to begin with. All right. What is the standard matrix for a reflection about the xy plane in R3? 1, 0, 0, 0, 1, 0, 0, 0, negative 1. What is a linear equation in the variables x1, x2, dot, 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 xn? And it's like a1 x1 plus a2 x2 plus dot, 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 plus an xn equals b. What is the standard matrix for a reflection about the xz plane in R3? 1, 0, 0, 0, negative 1, 0, 0, 0, 1. What are the 3 chapters of elementary linear algebra by Einstein? It's been months since I've had this question. Matrices and linear systems, determinants, Euclidean vector spaces, general vector spaces, eigenvectors and eigenvalues. It's like inner product spaces, quadraticalization, quadratics and something like, and then numerical methods, quadratic equations, quadratization. Damn it, what is that? Oh, okay, we missed something. Systems of linear equation, matrices good, determinants good, Euclidean vector spaces, general vector spaces, inner or eigenvalues and eigenvectors, inner product spaces. We got 6 for 6. Then these are combined diagonalization and quadratic forms, general linear transformations, then numerical methods. All right. What is the standard matrix for an orthogonal projection onto the xy plane in R3? Onto the xy plane in R3, standard matrix. 1, 0, 0, 0, 1, 0, 0, 0, 0. What is the standard matrix for an orthogonal projection onto the yz plane in R3? 0, 0, 0, 0, 1, 0, 0, 0, 1. What can you say about the number of solutions of a linear system? It either has no solutions, infinitely many solutions, or one solution. What is the standard matrix for a linear operator that rotates each vector in R2 clockwise about the origin through an angle theta? Cosine theta, sine theta, negative sine theta, cosine theta. What is the effect on the solution set of a linear system if an elementary row operation is performed on its corresponding augmented matrix? What is the effect on the solution set of a linear system if elementary row operation is performed on its... there's no change to the solution set. What is the standard matrix for an orthogonal projection onto the xz plane in R3? 1, 0, 0, 0, 0, 0, 0, 0, 1. What is the standard matrix for a reflection about the yz plane in R3? Negative 1, 0, 0, 0, 1, 0, 0, 0, 1. What can you say about the number of solutions of a consistent system of linear equations? Got one or infinitely many. All right. What is the standard matrix for an orthogonal projection onto the y-axis in R2? 0, 0, 0, 1. Yeah. What are the 9 chapters of elementary linear algebra by Anthony? Linear systems of linear equations and matrices, determinants, Euclidean vector spaces, general vector spaces, eigenvalues and eigenvectors, diagonalization and inner product spaces, diagonalization and quadratic forms, general linear transformations, numerical methods. All right, so from here, I'm gonna go ahead and grade what I did yesterday, and then we'll be back to go from there. All right, so I got the proof almost right. I just missed one thing. I basically said multiplying both sides on the right by the inverse of x, which x doesn't have an inverse as a vector, and I think only, if I'm remembering correctly, only square matrices have inverses, so you can't. But all I needed to really say instead was, since abx equals bax for all x, that's all I needed to say. Everything else besides that, you know, it's pretty verbose. It's pretty, maybe a lot of words, way more than I needed, but everything else seemed good. And then the rest of the true-false I did from yesterday were all correct, so I'm going to continue doing more practice problems now. I'll be back to recall in a little bit. All right. I'm done with this. G was basically saying is a reflection about the origin, the inverse of that transformation, an inverse of a reflection about the origin, a reflection about the origin. I said yes, because by definition, a reflection about the origin is a reflection over the x-axis and the y-axis, or the y and then the x, either way. But the inverse of that transformation is, again, another reflection over the x and another reflection over the y. So yes, I said true. And then final problem with the first pass of 1.9 was this technology problem, basically saying, find the standard matrix for the linear transformation on R2 that performs a counterclockwise rotation of 47 degrees about the origin, followed by a reflection about the y-axis, followed by a counterclockwise rotation of 33 degrees about the origin. So basically, here's the cosine, sine, negative sine, cosine that we just did on Anki. Rotation counterclockwise about the origin, 47 degrees, reflection about the y-axis, and then rotation counterclockwise around the origin about 33 degrees. Then I used MATLAB to multiply these three together and to get this value. So there we go. That's a first pass of 1.9 done. We're going to do another shorter pass the second time, and then we'll be into 110, which 1.10 is applications of linear systems. So that's it for today. Talk to you tomorrow. See you.